In this video, I will talk about the series solution method for integral equation. In this method, the unknown function is written as in series form n0 to infinity an xn a0 a1x plus a2x square so on. So what we do, we just put this series equation into the integral equation. So let me just solve an example. Suppose we have x square plus x cubed by 6 is equal to 0 to x 2 plus x minus t u of t. This is integral equation, and this is integral equation of first kind, and this integral equation is also called Volterra integral equation. This is equation 1, this is 2. So what we do, we put equation 1 into 2. Suppose we have 0 to x, 2 plus x minus t, and we can take only two values, two terms in the infinite series from equation 1, that is a naught plus a1. And remember that if there is an x, but here u is a function of t, which is unknown, so we can write a1t plus so on. You can take many terms as you like, but here we have taken only two terms, since I know that on the outside we have t over here. When we multiply this t, then you get the higher order. So first thing we need to do is just to simplify this problem. X square plus x cubed by 6 is equal to 0 to x. 2 plus x will act as a constant. So we multiply this 2 plus x with this whole term. So we have a naught plus a1t plus so on. The idea is to give you the methodology, how this method works. So how many terms you want to take is up to you, where we have a exact solution dt, and now we multiply this minus t minus 0 to x t a naught plus a1t plus so on dt. Next, we just need to integrate and get the answer. On the right hand side, x square plus x cubed by 6 is equal to 2 plus x is a constant, since the integration is with respect to t. So we integrate only this term. So here we get, the first we get a naught t, then we apply lower and upper limit, so we get a naught x. So finally we have a naught x. Similarly, when we integrate the second term, not this one but this one, a1t, so we have a1t square by 2, and the limit is from 0 to x, so that will be a1 x square by 2, so on. That is our first answer of right hand side, the first integration. Now we do minus 0 to x. Maybe I can just simplify it over here and integrate as well. So we have, when we multiply t with a naught, we get a naught t, and we have a naught t squared by 2 and 0 to x. So we have a naught x squared by 2, a naught x squared by 2 plus the second term we have a1 t square and we have a1 t3 by 3, but then we have x upper limit x cubed by 3, so on. That's why I kept only two terms, since I knew that we need to multiply this t with whole infinite series. Okay, so the only thing is left now is to get x on the left hand side and the power of x on the right hand side. So we have x squared plus x cubed by 6 is equal to, when we multiply 2 with all the terms a naught x plus a1 x squared. So we multiply 2 with a naught x, then multiply 2 with a1 x squared by 2. Similarly, we multiply x with a naught x, we get plus a naught x square. Then we have plus a1 x cubed by 2, x cubed by 2, correct, so on. And the next term we just need to multiply with minus. So we have, for example, minus a naught x squared by 2 minus a1 x cubed by 3 minus so on. Now compare the coefficients, comparing coefficients. First of all, we want to compare the value of x naught. On the left hand side, there is no x naught, so the value is 0 is equal to, and on the right hand side, there is no terms of any x raised to power 0. So 0 is equal to 0. So we do not get anything over here, that is 0. Now we want to see the coefficients of x1. On the left hand side, there is no coefficient of x. On the right hand side, we have the coefficient is 2a naught. So we have 2a naught plus, is there any coefficient of x? No, there is no any other coefficient, so a naught will be equal to 0. Then we have, for example, x2, the coefficients of x raised to power 2. On the left hand side, you can see that the coefficient is 1. So we have 1 is equal to, and the coefficient of x square, which is a1, plus the coefficient of x square, it is a naught, the coefficient of x square minus a naught by 2. So this term will be equal to, since a naught is 0, so we get a1 is equal to 1. That was a naught and a1. The last term, since we have x cube, the coefficient of x cube as well. So x cube is, on the left hand side, we have 1 over 6, and on the right hand side, we have a1 by 2. Then we have minus a1 by 3. Okay, that's what we have over here. So after, but this is already a 1, but I needed x cube. For x cube, we also have a1 and a1. So again, we will get most probably a1 is equal to 1. But if you just, I think this is the case, you can verify it. So we have, for example, if there would have been x raised to power 4, we could have been find a2 as well. Okay, since there is no x4, x raised to power 4 on the left hand side, so most probably we will get a2 is equal to 0, a3 is equal to 0, so on. These are all the coefficients of equation 1. This is our solution. In series solution, we write the solution in equation 1. So we have u of x is equal to a naught is 0, 0 plus a1 is 1 x plus a2 is 0, 0 x square, so on. All the other values will be equal to 0. So u of x is equal to x over here. This is the answer of integral equation 2. Now you can do one exercise yourself. The exercise is to solve. The question is solve x e raised to power x is equal to 0 to x e raised to power x minus t u of t dt. You can solve by series solution method. A very simple procedure. This is the same series solution that we use in the ordinary differential equation in ODE. Thank you for watching.